Hi everybody. Okay, so now we are working out of the intermediate algebra textbook, and we are evaluating and graphing exponential functions. So an exponential function is whenever you have your x variable in the exponent, okay? It also says that your base is greater than 0 and your base is not equal to 1, okay? Okay, so up until this point, we've been dealing with linear graphs. Notice that our x is to the first power. We've been dealing with quadratics. Most recently, our x is in the base and it's to the second power and also sometimes to the first, but nonetheless, your highest exponent is to the second power. And now we're working with exponential functions where we have our x up in the exponent. And in this case, the base happens to be 6, but the base can be anything that is a positive number, and also it cannot be 1, okay? All right, so it says here on the same coordinate system graph f of x is equal to 2x and g of x is equal to 3x. Okay, so we've got x and then we've got f of x for that first one. And for the second one, we've got x, and then we've got g of x. So we're going to create two different tables, and we're going to graph these on the same graph. All right, so let's start with, let's just use some numbers here. All right, so if I put -2 up here in the exponent, that would be 2 to the -2 power, which is 1 over 2 squared, which is 1 over 4. Okay, if I put -1 up in the exponent, I've got 2 to the -1 power, which is 1 over 2. If I put 0 up in the exponent, 2 to the 0 power, remember anything raised to the 0 power is 1. Then if I put 1 up in the exponent, 2 to the first power is just 2, and 2 up in the power, then I've got 2 squared, which is 4. Okay, so let's graph these. So -2 and then 1/4 is our y. So -2 and 1/4, that's approximately right there. Then I've got -1 and 1/2, which is about there. Then I've got 0 and 1, which is right there. Make this graph just a little bit bigger. And then we have 1 and 2, and then 2 and 4. So our graph actually looks like this. That's usually what an exponential graph looks like. It's curved, and it'll take a very sharp turn upwards. If it's a negative number, it goes like this. Okay, but if it's a positive number, this number, I mean the base, then it goes like this. But we're not going to worry about that right now. Okay, so let's start with the same numbers for x here. Okay, so if I put -2 in the exponent, that's the same thing as 1 over 3 squared, which is 1 over 9. If I put -1 up in the exponent, I end up with 1 over 3. If I put 0 up in the exponent, I end up with 1. If I put 1 in the exponent, I end up with 3. And if I put 2 up in the exponent, I end up with 9. All right, let's graph this now in purple. -2, 1/9. So that's even closer to 0, but not exactly. 1/3 be about there, so it's slightly below this. They both go through this same point right here. 1 and 3 goes right here, and then 2 and 9 is up here. Okay, so this one looks very similar. And notice that they both go through this point right here. That's what's you're going to find is very similar on all of these, because anything raised to the 0 power is 1. So all of your exponential graphs will go through 0 and 1. All right, let's do the same thing with these problems now. Very similar to the last one, except now we've got fractions as our base. Ooh, let's see what happens with those. So we've got, oh, here, I'm going to do function notation because that's what they're using. Okay, so we have, let's see here. Let's do the same ones again. Oh, there we go. Okay, so I've got 1/2 raised to the -2 power. That means I have, and I'm not going to do this for all the problems, but I do want to show you at least this first one. That means I have 1 to the -2 power, and I've got 2 to the -2 power. Flip-flop their places, because remember, the negative exponent means they don't like where they're located. So this would be just 4. Okay? And then, whenever I do the same thing with -1, I'm not going to really go through that math, but you end up with 2. Anything raised to the 0 power is 1. 1/2 raised to the first power is just 1/2. And then 1/2 raised to the second power is 1/4. Okay, so I'm going to go ahead and erase this work right here. So if you don't have it written down, you should get it that way. Okay. Now, let's graph this. -2, 4. -1, 2. Ooh, look at that. Look what's happening on this one. 0, 1. Notice it still goes through 0, 1. 1 and 1/2 is right there. And then 2 and 1/4 is right here. Okay, so notice that whenever our base is a fraction, it goes in the other direction. I think I misspoke earlier. I said that a negative number would make that happen, and that's wrong. It's when your base is a fraction or a number between 0 and 1, then that will give you that downward trend like that. All right, let's take a look at the g of x problem. All right, so let's use those same numbers. Okay, we know that this one's going to be 1, right? Okay, so whenever we have this raised to the -2 power, remember that makes everything swap, so we end up with 9. And then to the -1 power, we end up with 3. To the first power, we end up with 1/3. And to the second power, we end up with 1/9. All right, let's graph that. -2, 9 is right there. -1, 3 is right here. 0, 1 still goes through that spot. 1 and 1/3 down here. And then 1 and 1/9 is way close to 0, but not quite 0. By the way, this will never ever cross this x-axis. You can keep putting in numbers all day long and you will get super duper close to 0, but you will never ever cross that x-axis in an exponential function. Okay, let's do another one. All right, so let's see here, x and then f of x. Let's do the same numbers that we've been using. Okay, so whenever I put in -2, oops, hold on, -2 right here, 2 to the -2 is 1/4. 2 to the -1 is 1/2. We did this one earlier, so I'm just rewriting what we have. All right. Now, let's see what the difference is between this and whenever we add 1 in that exponent. So let me go ahead and graph that real quick. Oh. All right. Now, let's do x and then g of x. All right, do the same numbers here. All right, so now we've got, let's see here, I'll do the math up here, 2 to the negative 2 plus 1, which is 2 to the negative 1 power, which is 1 over 2. Okay, so now let's do the same thing up here. 2 to the negative 1 plus 1, which is really 2 to the 0, which is 1. Now, 2 to the 0 power plus 1 is really 2 to the first power, which is 2. Now, if we substitute in 1 right there, 1 plus 1 is 2. 2 to the second power is 4. And then if we do 2 to the 2 plus 1, so that's 2 to the third power, which is 8. All right, so negative 2, 1/2, so slightly above that one. Negative 1, 1. Ooh, look what that did. Now it won't go through 0, 1, will it? We had scooted it to the left, right? Okay. 0, 2, so now it goes through 0, 2. And then 1, 4, and 2, 8. All right, so look, here's what we've discovered. Whenever you're adding or subtracting up here in the exponent, then you don't go through 0, 1 anymore, do you? So that's only if you have just plain old x up there do you go through the 0, 1. Okay, so what happens whenever we don't have the minus or a plus in the exponent? It's now down here. Let's see what happens. All right, so let's do the first one. So whenever I put in negative 2 right here, 3 to the negative 2 power is 1/9. 3 to the negative 1 power is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. 3 squared is 9. All right, let's graph that. I don't know exactly where 1/9 is, but I do know that it's really, really close to 0. Negative 1, 1/3, slightly above that. 0, 1 is right there. 1, 3 right there. 2, 9 is up here. By the way, whenever you do your homework online, you only need 2 points to graph, okay? If you try to put any more than 2 points on your graph, it will mark it wrong. So make sure that you use any 2 of your points. Like I usually would use these 2 right here. I would use those 2 points, and then I would spot check with those other 3. All right, let's do the g of x now. All right, so let's do the same numbers. So if I have 3 to the negative 2 power minus 2, okay, so 3 to the negative 2 power is 1/9 minus 2, which would be 1/9 minus 18 over 9, because that's my common denominator. So I get negative 17/9, which, by the way, negative 17/9 would be about negative 1 8/9, which is basically negative 2. All right, let's do the same thing for negative 1. So I've got 3 to the negative 1 power minus 2, so that would be 1/3 minus 2, which is 1/3 minus 6 over 3. Negative 5 over 3. Negative 5/3, which is the same thing as negative 1 2/3. All right, so if I raise that to the 0 power, so I've got 3 to the 0 power minus 2, which is 1 minus 2, which is negative 1. And then I've got 3 to the first power minus 2, which is 3 minus 2, which is 1. And then 3 squared minus 2, which is 9 minus 2, which is 7. All right, let's graph those. Okay, so we're going to graph this now. Okay, so negative 2 and negative 1 and 8/9. So negative 2 and negative 1 and 8/9. Oh, look at that. It took us below that x-axis. So what happens? What does this do right here? What does that minus 2 do? It moves things down, doesn't it? Okay, so now let's see here. Negative 1 and negative 1 and 2/3. Okay, it's really going to be below negative 1 and 1/2. Okay, and then we've got 0, negative 1, which look at that. Our normal place to go through is right there. But what did this happen? It moved it down 2 spots. So that's what that does right there. It moves it down 2 spots. All right, and then we've got 1, 1. And then we've got 2, 7. All right. There we go. That's it. Again, when you're graphing, only use 2 points. I would probably use these 2 points or these two, but only use 2 points, and then you spot check with the other points. Okay, so this page won't make a whole lot of sense to you until I show you some examples, probably. All right, so it says your bases need to be greater than 0, so positive numbers, and it says that your bases cannot equal 1, okay? So what it says is that if you have the same base, let's say we have 4 and we have 4, and we have 4 to the x power is equal to 4 to the y power. As long as your bases are the same, as long as your bases are greater than 0 but not 1, then that means your exponents have to also be equal to each other. Okay, and I'm going to show you what I mean here in just a second. How to solve an equation, an exponential equation. Write both sides of the equation with the same base if possible, okay? Then write the new equation by setting the exponents equal to each other, solve the equation, and then check your solution. Again, you don't have to memorize this, but just something you need to read through and see if you're following the steps. Again, this is significantly more difficult um, to solve for x because the x is in the exponent, okay? So here's what you want to do. You want to have the same base. So can we write this number as something with a base of 3? Yeah, we totally can. Okay, so the left side, I'm just rewriting it. My right side, I'm going to write 27 as 3 to the third power, okay? As long as our bases are the same and the base is not a negative number or equal to 0, we're allowed to set the exponents equal to each other. And now we just solve for x at this point. All right, so our x is 4. Can you check your work? Totally. Let's check it. So we've got 3, and then we've got 2 times 4 minus 5. Does that equal 27? 2 times 4 is 8. 8 minus 5 is 3. Is 3 to the third power equal to 27? Yep, 27 equals 27, so this is the correct answer. All right, let's look at this one. So we've got 3 to the x squared minus 2x equals 1/3. Oh, so can we write this as something with a base of 3? Yes, we can. It would be 3 to the negative 1 power. Okay, so now I've got this and this are equal to each other. And in order to solve for an x squared, remember, we're either going to have to use the quadratic formula, completing the square, or we're going to need to factor. So I would pull everything over to one side. And so this factors to be, right, because it multiplies to be +1, but it adds up to be -2. And I take that and set it equal to 0. So x is equal to 1. All right, so now can we check our work? Yeah, we probably should too. All right, so we've got 3 to the 1 squared minus 2 times 1. Does that equal 1/3? I don't know. Let's see here. 1 squared minus 2 is, so 1 squared is 1. 1 minus 2 is -1. Yep, 3 to the -1 power is 1/3. So yeah, this is a great answer. Ah, look at this hot mess. All right. So the thing, anytime you are wanting to solve for a variable, you want to isolate the variable as much as you can. So move everything you can away from it. So the first thing I would do is I would move this 29 away from it. So I have 5 times 3 to the n power is equal to 405. All right, the next thing I want to do, again, I want to isolate that variable as much as I can. So I'm going to divide by 5. So 405 divided by 5 is 81. And so now, can I write 81 as something with a base of 3? Yeah, 3 to the 4th power is the same thing as 81. So I know that n is equal to 4. So can you check your work? Yeah. All right, so the first thing I would do, you do your exponents first. So you've got 5 times 81. That's what 3 to the 4th power is. 5 times 81 is 405. Add these guys together, and it works. So this is our solution here. All right, everybody, that's it for this video. If you have any questions or need any help, don't hesitate to reach out. Have a great day.